Okay, hello everyone. I welcome you once again for the one more problem which will be solving for the gate, which will be covering the maximum parameters which can be solved for this particular problem. I'll just read out the problem definition. The following data refers to two meeting involved gates of 20-degree pressure angle. The number of teeth on pinion is 20, gear ratio is 2, speed of the pinion is 250 rpm, module is 12 mm. If the addendum of each wheel is such that the path of approach and path of recess on each side are half the maximum possible length, each find addendum for both the wheels, length of arc of contact, maximum sliding velocity during approach and races. Okay, so these are the case which we have given. First we will be writing out the data which is been given here, already given. So given data, I'll be just writing it out. So what are the given data they have given? The data which is being given. First they have given is the pressure angle, that is phi is given as 20-degree here. Okay, next what they have given, uh, number of teeth on pinion, so that is TP they have given, it is 20-degree. Okay, so also they have given the gear ratio. So gear ratio is basically given in terms of Q, which is given as 2. Gear ratio has been given as 2. So according to our nomenclature, speed of pinion which will be N2. Okay, or you can write it as N1 also. So if you want to do, because N1 can be the driver, so I'll be writing it as N2 here. So this will be 250 rpm. Module is being given as 12 mm. Okay, this is the case, and one condition they have given, that is if the addendum of each wheel is such that the path of approach and path of recess on each side are half the maximum possible length. Okay, so we have already discussed about this formula here, so we'll be seeing that once again. Okay, so first what we'll be doing is we'll once again find out the angular velocity of this particular gear. Okay, angular velocity of this particular gear. So what is that? Pinion's angular velocity will be finding out, that is omega 2 is equal to 2 pi n2 divided by 60. So which is 2 pi n, that is 2 pi into 250 divided by 60. So you'll be getting it as 2 into pi into 250 divided by 60. So we'll be getting it as 26.16 radians per second. Okay, so what they have asked in the problem here is they have asked to find out addendum for both the wheels. So addendum means we have to find out the addenda of the circle. Also they have given a condition here. What is the condition they have given? The condition is if the addenda of each wheel is such that the path of approach and path of recess on each side are half the maximum possible, okay, length. So if you just observe the formula which we had discussed here, so this is path of approach, this is path of approach, path of recess. Path of approach and path of recess will be equal to half the maximum path, maximum length of path of approach they have told. So what is the path of approach? Path of approach is this formula, path of recess is this formula, which will be equal to maximum length, half the maximum length means r sin phi by 2. So what they have trying to tell here is, in the problem with the condition given, condition they what they have given is addenda, okay, addenda on both gears, okay, such that the path, the path of approach, and recess are half of their maximum possible value, values. So which means what? which means that if I want to write the path of approach, what is path of approach for gear? For gear, we will be writing it as RA square minus R square cos square phi, okay, R square cos square phi raised to 1 by 2 minus R sin phi should be equal to such that the path of approach of and recess is there. So first I'll write for path of approach should be half of this maximum value, means here the maximum value of length of approach is R sin phi. So I'll be writing it as R sin phi divided by 2 divided by 2. Similarly, for the recess I want to write, I will be writing it as RA square minus R square cos square phi raised to 1 by 2 minus R sin phi is equal to R into sin phi by 2. Pi by 2. Okay. So through this condition, I have to find out the values of these, the addendum radius and addendum radius for both gears and as well as the pinion, so that with respect to addendum circle, and if I know the pitch circle radius, I can find out the addenda. Okay, so we will be just observing here. So what they have given is, they have given the gear ratio here. So okay, they have given the gear ratio. Gear ratio is nothing but uh, if I take the gear ratio, Q is nothing but Tg by Tp. Tg by Tp, gear ratio it has been given. So what is the gear ratio they have given? They have given it as 2. I can find out the value of Tg here with the help of Tp. Tp is already given the number of gears, they have given it as 20 here. So it is 20 here. So Tg will be 40. Tg will be 40. Through this I can find out the value of pitch circle radius. It is easy to find out the pitch circle radius. So if I see here, capital R will be given the formula as, so from the previous you have taken it as mtg divided by 2, mtg divided by 2, where m is the module, so which we have taken here 12 mm. So 12 into 40 divided by 2, 40 divided by 2, you will be getting it as 240 mm, 240 mm. So similarly you can find out for pinion also, that will be smaller, that will be m into Tp divided by 2, so which will be 12 into okay 12 into, what is Tp here? Tp is 20, so 20 divided by 2, so it will be 120 mm, 120 mm. So if I substitute this values of R in this above equation, I can find out the value of the addendum radius, okay. So if I just substitute here, what will be getting? So if I take this equation as A and equation as B, okay, so what is the equation you have? You have R square A minus this, we have R square, capital R square, so that will be 240 square cos square, how much is the pressure angle here? 20 degree, okay. This will be 1 by 2 minus R sin phi, that's sin 20, okay, sin 20 should be equal to 120, that is small r here, so this is small r here, 120 divided by sin 20 divided by 2, so if you solve this equation, okay, so how to solve this? So just shift the other one sign terms on that side, okay. So then it is the root term here is the root term. So if you shift the root term on the other side, so this, if you can solve it as 240 square. So I'll just write down the values. So what we'll be getting here is R square A minus, if I solve this, I'll be getting 50862. This will be the root parameter. So minus 82.08 should be equal to 20.52. 20.52. So if you solve this, RA, you will be getting it as 247.77 mm. Okay, so you got RA now. So you know the RA formula. RA is nothing but capital R plus addendum, addenda of gear. So if I want to find out the addenda of gear, so it will be RA minus R, addenda. Okay, so it is 247. Okay, it is 247.77 minus 240. So you will be getting it as 47. No, not 47. It is 7.77 mm. Okay, so similarly, you have to find out on the other ground, that is RA square minus R square cos square phi into 1 by 2 minus R sin phi should be equal to capital R sin phi divided by 2. This is the formula you have. So similarly, you have to substitute the values here. So this is RA square minus small r is how much you have got, 120. Okay, so it will be 120 square cos square 20 into 1 by 2 minus 120 sin 20 equal to 240 sin 20 divided by 2. So if you solve this, what you will be getting is RA square minus 12715.52, 1 by 2 it is minus 41.04 should be equal to 41.04. Okay, so what you will be getting, RA you will be getting it as 139.5 mm, 139.5 mm. So if you want to find out the addenda here, so you will be getting it as RA minus R. So RA is 139.5, R is 120 degree, so 120 mm. So you will be getting it as 19.5 mm, 19.5 mm. So you have solved the first part, that is finding the addendum for both the wheels. So next he has asked to find out the length of arc of contact, LAC. Okay, so LAC he has asked. Okay, so if I want to find out the length of arc of contact, you can easily find out, that is you can find out by path of approach. Okay, path of approach and path of recess here. So path of recess, length of arc of contact is LP. Okay, so that is LPC divided by cos. So if you see the formula here, okay, if you see the formula here, length of arc of contact is LPC divided by cos phi. So you can easily use that formula to solve the problem, or you have to find out this part. Okay, so I think already you have found out the right hand side. So if you just use this right hand side here. Okay, so whatever you have found out here, okay, so whatever this just if you observe here, whatever is there on this side, it is nothing but the length of arc of contact. Okay, so once again you can find out the same thing here. So first will be find out the path of approach, which is given as PL. Okay, which is given as PL, which is nothing but RA square minus R square cos square phi into 1 by 2 minus R sin phi. Okay, so this will be the length of path of approach. So which is RA you have already found out. This is the value of RA. Okay, so if you solve this, you will be getting that is 247.77 square minus 240 square cos square 20 raised to 1 by 2 minus 240 sine 20. So if you solve this, so you will be getting it as 20.52 mm. So path of recess that is Kp will be given as Ra square minus R square cos square phi is to 1 by 2 minus R sine phi. Okay, so which is nothing but you have a small array here 139.5, so it will be 139.5 square minus 120 square cos square 20 raised to 1 by 2 minus 120 sine 20. Okay, so if you solve this, you will be getting it as 41.08 mm. 41.08 mm here. Okay, so if you add both, you will be getting the LPC, length of path of contact. So length of path of contact is given as PL plus KP, which is nothing but 20.52 plus 41.08. So you will be getting almost 61.60 mm. Okay, 61.60 mm. So length of what they have asked in the problem is length of arc of contact. They have asked, it is nothing but length of point of contact divided by cos phi. Okay, so divided by cos phi, so which is 61.60 divided by cos 20, so you will be getting it as 65.51 mm. 61.51 mm. So in the problem, what they have asked is to find out length of arc of contact, okay, and maximum sliding velocity during the approach and recess. So maximum sliding velocity will be with respect to the path of approach and path of recess. So maximum sliding velocity. So this is second part here, this is third part, velocity at engagement GAGMENT, so which will be equal to whether we have found out the basic formula for this is omega 1 plus omega 2 into PL, that is path of approach. So whether we have found out omega 2 here, omega 1 here, okay, we have not done that. Okay, so we can find out that also easily. So we know that basically TG by TP, okay, TG by TP is nothing but omega 2 divided by omega 1. Okay, so if I want to find out omega 1 by omega 2 is equal to TP by TG, so omega 1 is TP is how much, 20 here, TG is how much, 40 here, into omega 2, so which is 1 by 2 into 26.16, so we'll be getting it as 13.08 radians per second. So it is nothing but one is 13.08 plus 26.16 into 20.52. So we will be getting that as 805.20 mm per second. Okay, so everything is in mm. So similarly, maximum sliding velocity at disengagement is basically given as omega 1 plus omega 2 into kp. So which is that is how much, 13.08 plus 26.16, we can call it as 41.08 is nothing but equal to how much we will be getting, we will be getting it as 1611.97 mm per second. Okay, mm per second. So these are the three different values we have got it. So in the exam similar type of problems will be there, so where some conditions will be given. So we need to know all these formulas here, whatever the formulas I have told you. Okay, so you have to remember these formulas and try to uh, memorize them, so that should not be any issue. Clear? So in the coming classes I'll be telling you about the gear trains. Okay, so thank you.